हेलो बच्चे, आज हम लोग डाइपोल मोमेंट डिस्कस करेंगे। व्हाट इज़ डाइपोल मोमेंट, राइट। तो डाइपोल मोमेंट क्या होता है? इट इज़ द मेजर ऑफ इलेक्ट्रोनेगेटिविटी डिफरेंस। इट इज़ द मेजर ऑफ electronegativity difference, right? Dipole moment, it is the measure of electronegativity difference. Okay, now this dipole moment is denoted by the symbol mu, right? And this mu is expressed as E multiplied by D. This is the equation of dipole moment. And what is the meaning of this terminology, right? This D is the distance between two atoms, distance between two atoms, right? And E is the charge, and charge will be on the basis of electronegativity difference. Electronegativity difference, right? And you have to remember one point here, that this dipole moment, it is a vector quantity, right? This is a vector quantity, right? If I talk about HCl molecule, right, and we know this bond is made up of two electrons, right? Now we know chlorine is more electronegative as compared to hydrogen. As a result, chlorine will attract the shared pair of electron towards itself. As a result, this chlorine will acquire slightly negative charge and hydrogen will acquire slightly positive charge, and there is a measure of electronegativity difference, right? And we can say this HCl molecule is polar. It has a dipole, right? It has a dipole. So you can remember from here that electronegativity difference, right, it is directly proportional to polarity of molecule, right? Polarity of molecule, and polarity of the molecule, polarity of molecule, it is directly proportional to dipole moment, right? You will remember this. And what is the unit of dipole moment? Unit of dipole moment, it is 1 dB, right? DEBYE, dB, right? And its value is 1 into 10 raised to power minus 18 electrostatic unit, right? Electrostatic unit, right? And in terms of, we can write here centimeter, right? And in terms of coulomb meter, it is 3.33 into 10 raised to power minus 30, 10 raised to power minus 30 coulomb meter, coulomb meter, right? In dipole moment, three types of questions can be asked. But before going into the detail of this dipole moment, I will tell you that this dipole moment, it is opposite of Fajan's rule. It is opposite of Fajan's rule. We have studied what are Fajan's rule. Fajan's rule tells us how much covalent character, is present in ionic compounds. But dipole moment it is used to find percentage of ionic character in covalent compound. Right? So we have HF molecule, right? HF molecule, and this fluorine is more electronegative, right? It will attract these shared perfect electron toward itself. As a result, it will carry slightly negative charge and it will carry slightly positive charge. We can say this molecule is polar due to electronegativity difference, right? We have hydrogen bond hydrogen and the electronegativity is same. This is non-polar, right? Electronegativity same. Is it clear? Okay. Now if we talk about, this is very important point, if we talk about BF3, right, boron, fluorine, and fluorine, there is also the electronegativity difference, right? Fluorine is more electronegative than boron, right? There is electronegativity difference. This molecule should be polar, but this molecule is non-polar, right? Polar. We will understand why, right? This should be polar, but this is non-polar. Why? Right? So this molecule is non-polar due to this molecule is non-polar due to dipole moment, right? How? We will understand this concept, right? First of all, if I will explain this molecule. We have a BF3. Now we have to show the dipole moment in this way. Chlorine is more electronegative than boron. Fluorine is more electronegative than boron, and fluorine is more electronegative than boron. This is the arrow representation for showing this dipole moment. Now here we have this dipole in this way, right? If we take the resultant of the dipole moment, here the net dipole moment will be 0 in this molecule, and when net dipole moment is 0, the molecule is non-polar, right? In this way, if I extend this in this way and here, right, this is also the dipole moment, this is also the dipole moment, and this is also the dipole moment, right? This is mu cos 30 degree, right, because this is 30 degree angle here, and this is also mu cos 30 degree, right? At one place we have mu sin 30 degree. When we will take the resultant of these two, mu cos 30 degree plus mu sin 30 degree, we will get the dipole moment, and the overall dipole moment will be 0 here, right? In this way, although polarity is present here, but due to net dipole moment equivalent to 0, this molecule is non-polar, right? So from here we have to remember, if net dipole moment comes to be 0, the molecule is non-polar, and if net dipole moment is not equivalent to 0, the molecule will be polar, right? And direction of the dipole moment is from, right, towards the more electronegative atom, less electronegative atom to more electronegative atom, right? In this way, as HF, right? F is more electronegativity, we write dipole moment here as, right? But when lone pairs are present, are present, then how this dipole moment will be represented? It will be represented as in this way, right? Atom to lone pair, atom to lone pair, right? Now for finding the dipole moment, first of all we have to identify the type of compound. Identify the type of compound, right? Whether the compound is polar or non-polar, right? Suppose we have A bond B, right? In one bond between two atoms, if there is electronegativity difference, then the bond is polar, right? But in case of molecule, whether it is polar or non-polar, which has more dipole moment, right? We have to calculate, right? If we have a molecule, whether it is polar or non-polar, we have to calculate dipole moment, right? Which has more dipole moment, right? And after that we can calculate percent ionic character, right? So first of all, there are some factors which affect the dipole moment. Factors which affect the dipole moment. First factor is, more is the electronegativity difference, more is the dipole, right? So mu is directly proportional to charge. E is the charge due to electronegativity difference, right? And next factor is this dipole moment, it is directly proportional to distance between two atoms, right? More is the distance, more is the dipole moment, right? And third thing, this dipole moment, it is inversely proportional to the angle between two atoms, that is theta, right? You have to remember this. Now if we talk about the polyatomic molecules, polyatomic molecules, right? Angle between two atoms, angle between two atoms. When two dipole moments of same molecule are present at 120 degree between two atoms, right? When two dipole moments of same molecule are present at 120 degree, right, between atoms, the resultant dipole moment is equal to individual dipole moment, right? The resultant dipole moment will be equivalent to individual dipole moments, but surrounding atom should be same. Surrounding atom क्या होना चाहिए? Same होना चाहिए. Is it clear? Right? Suppose we have the central atom A, one atom is B here and other atom is B here. Now suppose this B is more electronegative than A, right? And the angle between these two dipoles is 120 degree, right? This is dipole moment first, this is dipole moment second, and this B is more electronegative than A. We have to take the resultant. The resultant will be in this way, right? Resultant dipole moment. And in this way, if we talk about the resultant, this mu1 will be equivalent to mu2, right? And we have the one formula in physics, right, that mu resultant it is given by under root of म्यू 1 का स्क्वायर प्लस म्यू 2 का स्क्वायर प्लस 2 म्यू 1 म्यू 2 cos theta, right? Cos theta, right? Here theta is 120 degree and cos 120 degree, this value is minus 1 by 2, right? So mu resultant, it is equivalent to this mu resultant, it will be equivalent to म्यू 1 का स्क्वायर प्लस म्यू 2 का स्क्वायर प्लस 2 म्यू 1 का स्क्वायर cos of 120 degree, right? Because म्यू 1 equivalent to म्यू 2, so we have written in case of म्यू 2 म्यू 1, that is why म्यू 1 का स्क्वायर. Now this mu resultant we can write here also mu 1, right? And this will become 2 mu 1 का square plus 2 mu 1 का square into cos 120 degree is minus 1 by 2, right? Mu resultant is equivalent to this 2 and 2 will get cancelled. 2 mu 1 का square minus म्यू 1 का स्क्वायर अंडर रूट, right? And finally we will get this mu resultant will be equivalent to under root म्यू 1 का स्क्वायर, this square root and square will be cancelled and mu resultant is equivalent to mu, right? So if the dipole moment is inclined at an angle of 120 degree, then net resultant dipole moment will be, if this is mu 1 and this is mu 2, then net resultant dipole moment, it will be equivalent to mu, right? We have to remember this. Okay, तो इस वीडियो में हम यहीं तक स्टॉप करते हैं. ओके.